Hello, ma'am.
Good evening, sir. You can start.
Good evening, sir.
Yeah, Ajay. Good evening. What, Ajay, for lunch today?
Sir, nothing special, sir.
Why? Why no special?
Sir, normal school day, sir, so nothing special.
Oh, okay. What chapter will you do next after this?
Sir,
Hmm.
sir, aldehyde ketone carboxylic acid, sir.
Well, we'll continue with organic chemistry only.
Yes, sir.
Okay. So many reactions are there. So we'll rush through today. Yesterday we learned in detail the reaction of the preparation and the reactions of carbon tetrachloride, not carbon tetrachloride, chloroform. So iodoform is triiodomethane. Chloroform is CHCl3 and iodoform is CHI3. Iodoform resembles chloroform in the methods of preparation and properties. Now you should remember this chloroform is a liquid, iodoform is a pale yellow solid. Pale yellow solid, iodoform is a solid. Now preparation, ethanol when you allow it to react with iodine, ethanol when allowed to react with iodine, it undergoes oxidation to form acetaldehyde giving you 2HI. Likewise, now this acetaldehyde, further when you react it with iodine, these 3 hydrogens and 3 iodine gets eliminated as 3HI. In place of this 3 hydrogen, you get 3I. So you get Ci3CHO. If you remember, we have learned something called as CCl3CHO. I would have called it as trichloroacetaldehyde, or we would have named it as chloral, the common name. Similarly, here you can see iodal, IODAL, Ci3CHO, triiodoacetaldehyde, iodal. This iodal, when allowed to react with aqueous potassium hydroxide, potassium formate gets eliminated as a byproduct, giving you CHI3. CHI3. This is a solid, pale yellow solid, and called as iodoform. It is similar to the preparation of aldehyde, chloroform. Similarly, if you take acetone, when you react with iodine, these 3 hydrogen is replaced by 3 iodine. See, 3I2, we are writing it for our convenience as C3I and 3I. This 3I and 3H gets eliminated as 3HI. In place of this H3, 3I goes. Therefore, you get triiodoacetone. This triiodoacetone, when you react with potassium hydroxide, we get iodoform and you get potassium acetate. So these reactions you have to write and practice. Now, industrial preparation. Iodoform is prepared in large scale by electrolysis of a solution containing ethanol, sodium carbonate, and potassium iodide. So when we electrolyze the mixture of ethanol, sodium carbonate, and potassium iodide, iodine is set free, which combines with ethanol in the presence of alkali to form iodoform. So by electrolysis, you know electrolysis is by passing current. The electrolysis is carried out in the presence of carbon dioxide, and the temperature maintained is around 60 to 70 degrees, right? This is the reaction which takes place. So Ki gives you K plus and I minus. At cathode, reduction takes place. We have learned redox reactions in detail. At cathode, K plus moves and it undergoes a reduction to form K. At anode, iodine goes, it loses electrons to form what? I2. This is the reaction. And this KOH is neutralized by carbon dioxide. Because KOH is a base, it gets neutralized by carbon dioxide. This iodine, which is liberated, reacts with ethanol to form iodoform. This is how iodoform is prepared by electrolysis of ethanol, potassium iodide, and potassium hydroxide. Physical properties, we just told you, it is an yellow crystalline solid. It has a pungent characteristic odor. It is insoluble in water, but soluble in organic solvents like alcohol, ethers. Melting point is 119 degrees Celsius. Chemical properties, they won't add much of chemical properties on iodoform. Chloroform is important, but still you can have this set of reactions. Iodoform with KOH hydrolysis, it gives potassium formate. Iodoform when reduced, you get methylene iodide. Iodoform on heating with silver powder, you get acetylene. Iodoform reacts with the now primary amines and KOH to form isocyanates. If you remember, yesterday we learned methyl amine when it is heated with potassium hydroxide and chloroform, CHCl3. This 3Cl and 3K gets eliminated as 3KCl, and you have 3OH, and you have 1 hydrogen here and 2 hydrogen here, gets eliminated as 3H2O. And what else you have now? CH3N, and you have this C. This is called as isocyanates, isocyanate formation. Instead of using CHCl3, we can also use CHI3, iodoform. The same product will be formed. Here they have used aniline, primary amine, gives you phenyl isocyanate. So iodoform, again on heating, you get iodine vapors with the liberation of carbon monoxide. Next, when iodoform is allowed to react with silver nitrate, we get an yellow precipitate of silver iodide. Because AgNO3 will give you Ag plus and NO3 minus. This Ag plus will react with I to form an yellow precipitate of silver iodide. This reaction is not given by chloroform. So chloroform does not react with AgNO3 because chloroform does not give free chloride ions. Therefore, this reaction is not shown by chloroform. So iodoform is extensively used as an antiseptic for dressing the wounds. You would have heard something called as tincture of iodine. Tincture you would have heard. So this is nothing but tincture of iodine. All right. So it is used as an antiseptic. But antiseptic action is due to the liberation of free iodine and not due to iodoform itself. So it is behaving like an antiseptic not because of iodoform. It is because of liberation of iodine. That's why it's called as tincture of iodine. When it comes into contact with organic matter, iodine is liberated, which is responsible for antiseptic properties. Test for iodoform. With silver nitrate, iodoform gives an AgI, yellow precipitate of AgI. Carbylamine reaction, I told you just now, I wrote a primary amine like methyl amine. When it is heated with iodoform, CHI3, in the presence of alcoholic potassium hydroxide, so K and I gets eliminated as 3Ki, 3 OH groups, 1 and 2 hydrogen gets eliminated as 3H2O. And what else is left out? You have CH3 and you have what? NC, which is called as isocyanate. These are isocyanates are called as carbylamines, which have an offensive smell. It is very dangerous. You cannot keep inhaling this isocyanates for a long time. It causes death. So iodoform reactions. So iodoform reactions with iodine and sodium hydroxide or iodine and sodium carbonate. Iodoform test is mainly given by ethanol, acetaldehyde, alpha methyl ketones, secondary alcohols, secondary alkyl halides. These are the list of compounds which will give you iodoform test. Next is carbon tetrachloride. I have to finish this chapter quickly so that I can go for alcohols and ketones. That's why I'm rushing through. Now, carbon tetrachloride is CCl4. It's a tetrahalide. When methane is chlorinated at 400 degrees Celsius, you get carbon tetrachloride. See, this 4-chlorine, we can write it as 4Cl and 4Cl. Cl2, I can write it as 4Cl and 4Cl, totally 8 chlorine atoms. this 4Cl and 4 hydrogen gets eliminated as 4HCl. And in place of the other 4 hydrogen, 4Cl goes. Therefore, you have carbon tetrachloride. We can also prepare carbon tetrachloride from carbon disulfide. When carbon disulfide is chlorinated in the presence of iron or aluminum chloride as a catalyst. So what happens is, now you get sulfur monochloride. So S2 and Cl2 will give you S2Cl sulfur monochloride, and in place of S2, 4 more chlorine goes. We have 6 chlorine, so I can write it as 4Cl and 2Cl. This 2Cl and S2 gets eliminated as S2Cl2. In place of S2, 4Cl goes. Therefore, we get carbon tetrachloride, second method of preparing carbon tetrachloride. This S2Cl2 further reacts with carbon disulfide to form more carbon tetrachlorides. So here CS2 plus 2S2Cl2 gives you carbon tetrachloride and 6S sulfur. So 6 sulfur gets eliminated, and what you have? Carbon, you have 4 chlorine atoms gets bonded to form carbon tetrachloride. So preparation of carbon tetrachloride from propane. Propane is C3H8. When propane is chlorinated at 400 degrees Celsius and 70 to 100 atmospheric pressure, you get carbon tetrachloride, hexachloroethane, which is a solid, with the liberation of hydrogen chloride. This is not in the syllabus. It is not in the syllabus from propane. Now, properties, physical properties. Carbon tetrachloride is a colorless liquid. It has a characteristic smell. It is non-inflammable and it is poisonous. It has a boiling point 77 degrees. It is insoluble in water but soluble in organic solvent. It is an excellent solvent for oils, fats, waxes, and grease. Chemical properties. Carbon tetrachloride is less reactive and inert to most of the organic reagents. However, following reactions are observed. The first one is reaction with steam. Carbon tetrachloride when reacted with steam at 500 degrees Celsius. Now, 2 chlorine and 2 hydrogen can get eliminated as 2HCl. In place of the 2 chlorine, oxygen gets eliminated. Now we can write this equation for our convenience like this. Cl2, Cl2, and when it's allowed to react with steam at 500 degrees Celsius, what happens? This is H2, sorry. This is H2O. So what happens? This 2 hydrogen and 2 Cl gets eliminated as 2HCl. In place of this 2 chlorine, oxygen goes. So you get COCl2. This is called as phosgene. Carbonyl chloride is called as phosgene, which is a poisonous gas. And again, carbon tetrachloride on reduction with iron and water. Carbon tetrachloride on reduction. So I can write this as CCl and Cl3. This on reduction, in the presence of reduction is addition of hydrogen. 1 hydrogen and 1 chlorine gets eliminated as HCl. In place of that chlorine, hydrogen goes, so you get CHCl3, chloroform. So that carbon tetrachloride on reduction gives chloroform. Are you following something, students?
Yes,
Are you
sir.
there? Yeah. Yes.
Yes, sir.
Yeah. Next is carbon tetrachloride on hydrolysis with aqueous potassium hydroxide. Aqueous potassium hydroxide. So this 4 chlorine is reacting with 4K to form 4KCl, which is eliminated as a byproduct. In place of 4Cl, 4OH goes. So carbon containing more than 1 OH group is unstable. Carbon containing more than 1 OH group is unstable. Here, carbon contains what? 4 OH group, therefore it is highly unstable. When highly unstable, it decomposes. It decomposes to give 2 water molecules. See, this 1 water molecule gets eliminated, and here 1 more water molecule gets eliminated. So 2 water molecule gets eliminated, therefore you get carbon dioxide. Carbon dioxide. This carbon dioxide is acidic in nature. Since carbon dioxide is acidic in nature, it will react with potassium hydroxide. This potassium hydroxide to form potassium carbonate and water. It's a salt formation, neutralization reaction, since carbon dioxide is acidic in nature. So when carbon tetrachloride is hydrolyzed with aqueous potassium hydroxide, the final product formed is potassium carbonate. Potassium carbonate. Next. Reaction with phenols. Yesterday I taught you Riemann-Tiemann reaction in carbon tetrachloride. So chloroform, carbon tetrachloride, and sodium hydroxide gives salicylic acid. Salicylic acid formula I wrote like this, if you remember. And I told you I will teach the reaction mechanism in the next chapter. This is called as salicylic acid. What are the uses of chloroform? It is used as a fire extinguisher under the name pyrene. So chloroform is used as a fire extinguisher under the name pyrene. And the dense vapors form a protective layer on burning objects and prevent the oxygen or air to come in contact with the burning object. So fire extinguisher, chloroform, carbon tetrachloride is used under the name pyrene. The dense vapors form a protective layer on the burning objects and prevents the oxygen or air to come in contact. Therefore, what happened? The fire can get subside. It is used as a solvent for oils, fats, waxes, and grease. It is used in medicine as helminthicide for elimination of hookworms. It's also used as a medical component. Now, next is unsaturated halides. This unsaturated halides we do not have in our syllabus because the name itself is haloalkanes and haloarenes. So I've just given you one or two slides based on unsaturated halides, haloalkanes, like vinyl chloride, synthesis of vinyl chloride. It can be synthesized by a number of methods given below. See, ethylene chloride with aqueous potassium hydroxide, you will get vinyl chloride. Likewise, so many methods are there. These all are not in the syllabus, but for competitive exams, you may have to know. That is why I have just put these things. Haloarenes we will learn now. We will learn haloarenes. So with haloalkanes we have done. These all are haloarenes. So some of the questions. Now, why chloroform? Before we go for haloarenes, we will learn some of the questions. Chloroform is kept in dark colored bottles because it reacts with clear glass. It undergoes chlorination in transparent bottles. It gets oxidized to a poisonous gas, phosgene, in sunlight. It starts burning when exposed to sunlight. So carbon monoxide, as a chloroform, gets oxidized. So this chloroform CHCl3, when it is exposed to atmospheric air, what happens? It gets oxidized in the presence of sunlight to form phosgenes, COCl2. Yesterday we were learning phosgene and 2HCl. I told you it is a poisonous gas. So therefore, this chloroform is kept in dark colored bottles and it is stored up the brim. Yesterday we were learning. So it gets oxidized to poisonous gas, phosgene. Triiodomethane is as an antiseptic property because of liberation of iodoform, liberation of free iodine, formation of phosgene gas, none of these. Today we learned it is due to the liberation of free iodine. Iodine which is liberated, that acts as an antiseptic. Next, the third question. The fire extinguisher pyrene consists of or contains. Pyrene contains what? Carbon tetrachloride. Pyrene is other name for carbon tetrachloride. We were learning now. The next one. An organic halogen compound which is used as a refrigerant in the refrigerator and air conditions. What is
CCl4.
that? CCl4. It is chlorofluorocarbons, freons. Chlorofluorocarbons. It is not carbon tetrachloride, it is chlorofluorocarbons. CFCs, it is called as freons. So therefore the answer for this question will be option C. All right, not carbon tetrachloride. It's a product of carbon tetrachloride, substituted products of carbon tetrachloride. Which one is correct? Freon 14 is CF4. See, so many freons we have. Freon 14, Freon 13, Freon 12, and Freon 11. So which one is correct? Freons are chlorofluorocarbons. Freons are used as refrigerants, all the above. So which one is correct? All the
Sir,
above is
all the
correct.
above.
Freon 14, yeah, Freon 14 is CF4, Freon 13 is CF3Cl, Freon 12 is CF2Cl2, and Freon 11 is CFCl3. All are true. The next question. Which one of the following is correct? No, sixth one, right? Which of the following is responsible for depletion of ozone? The ozone layer in the upper strata of the atmosphere. Polyhalogens,
Sir, freons.
freons. Freons is one of the component, all right, for ozone depletion. And another one is nitric oxide. Nitric oxide is an effluent in aeroplanes. AER, aeroplanes, all right, supersonic jets. So all these nitric oxides, will react. Nitric oxide will react with ozone, and you get what? Nitrogen dioxide and oxygen. So ozone gets depleted because of nitric oxide. Along with that, this chlorofluorocarbons also will deplete ozone. Now, the next one is which one of the following is correct? Reduction of an aldehyde gives secondary alcohol. The reaction of vegetable oil with sulfuric acid gives glycerin. Alcoholic iodine with sodium hydroxide gives iodoform. Sucrose on reaction with sodium chloride gives invert sugar. Now, ethanol, when reacted with iodine and with sodium hydroxide. See, alcoholic iodine means ethanol and iodine. So this gives us iodoform, an yellow precipitate. So therefore, the answer for this question is option C, alcoholic iodine. Alcoholic iodine with sodium hydroxide gives iodoform. Next, phosgene is commonly called as COCl2. It is commonly called as carbonyl chloride. It is called as carbonyl chloride. Hence, the answer is option D. Chloroform CHCl3 when it is oxidized in the presence of air, right, and light, sunlight. So you get COCl2 plus HCl. So this COCl2 is called as phosgene, carbonyl chloride. Haloarenes. Now we are coming to haloarenes. What are haloarenes? Arenes are ring compounds. In these compounds, halogen is linked directly to the carbon atom of the benzene nucleus. So whenever halogens are directly bonded to carbon atom of the benzene nucleus, then we call that as haloarenes. Nomenclature, common name is aryl halides. IUPAC name is haloarenes. Aryl halides is the common name. Haloarenes are the IUPAC name. Now, excuse me. Now you can see this is benzyl chloride. The IUPAC name is chlorobenzene. This is benzyl bromide. The IUPAC name is bromobenzene. You can see the common name is aryl halide. Aryl group is benzyl group and halogen. Therefore, it's benzyl chloride and it's benzyl bromide. But the IUPAC names are chlorobenzene because haloarenes, chlorobenzene, parent molecule is benzene. Therefore, substituent is chlorine, chlorobenzene. Here also, parent molecule is benzene, substituent is bromine. Therefore, it's called as bromobenzene. Now, how can we prepare haloarenes? The preparation of haloarenes, we will learn what is given in your material, we will learn, and then later we will go, all right? The first one is, we can prepare haloarenes by electrophilic substitution of aromatic hydrocarbons. So electrophilic substitution reactions of aromatic hydrocarbons. Now, what is that? Now, for an example, if you take this molecule, what is the name of this molecule? What's the name of this molecule?
Benzene, sir.
Benzene. What is the name of this molecule?
So still benzene.
It is still benzene. Now, when benzene is allowed to react with chlorine, in the presence of ferric chloride as a catalyst, I'm giving you the overall reaction. I'm not teaching you the mechanism. Mechanism, you should have learned it in the 11th standard. So H and Cl gets eliminated as HCl. In place of H, this chlorine goes. So therefore, the product what we get is chlorobenzene. Chlorobenzene is an example for haloarenes. Electron deficient groups. Electrophile means electron deficient group. Now, this electron deficient groups are called as electrophiles. In chlorination, the electrophile is chloronium ion. What is the electrophile in chlorination? It is chloronium ion. So chloronium ion is Cl plus. Generally, we talk Cl minus, chloride ion. But here, during the mechanism, what happens is Cl plus will be formed. Chloronium ion is formed. So this chloronium ion will attack the carbon atom of the benzene ring to form chlorobenzene. So you should remember, what is an electrophile in chlorination? The electrophile in chlorination is chloronium ion. All right. Now, the second method of, this is one of the method of preparing haloarenes. Now, we will see what is the method given here. The second method of preparing haloarenes is from diazonium salts. Now, this is what I've taught you now. This is what I taught you, halogenation. If we chlorinate, you'll use what? Ferric chloride. All right, this is what we learned. Now, the next one is from aniline. Now, aniline is C6H5, NH2. This is aniline. So how aniline is prepared? Firstly, we will try to understand the reaction of aniline and NaNO2 and HCl, sodium nitrite. Now, if you would remember, this is called as benzene diazonium chloride. This is called as benzene diazonium chloride. Right. Now, we will learn the preparation of benzene diazonium chloride, and then we will learn the preparation of the other haloarenes. Now, I'll erase this part. The second method of preparing haloarenes is from diazonium salts. From diazonium compounds, from diazonium compounds. What does this azo means? Azo means nitrogen containing compound. Azo means nitrogen containing compounds. All right. Diazo means two nitrogen atoms a molecule will possess. Therefore, it will be called as what? Diazonium compounds. Now, first part of the reaction is a reaction between sodium nitrite and HCl. Sodium nitrite and HCl. What happens? The sodium nitrite and HCl, what happens is, you see here, what is this? H and NO2 gives you what? HNO2 plus what you will get? NaCl. What is this HNO2 called as? This HNO2 is called as nitrous acid. HNO2 is called as what acid? Nitrous acid. HNO3 will be called as nitric acid. See, this nitrous acid cannot be prepared and kept because it's unstable. So whenever it's required, we prepare nitrous acid by the reaction of salt, sodium nitrite, NiTRIT, nitrite with HCl to form nitrous acid. Now this nitrous acid will react with aniline. Nitrous acid will react with aniline. What's the formula of aniline? The formula of aniline is C6H5NH2. This is aniline. Nitrous acid will react with aniline in the presence of HCl. So nitrous acid, I will write it like this: O double bond N and OH. You see here, HNO2, nitrous acid, in the presence of HCl at 0 to 5 degrees Celsius. It has to be cooled. At very low temperature, this reaction takes place. So what happens is this H2 and O gets eliminated as water. And this OH and H also gets eliminated as water. So how many moles of water gets eliminated? 2 moles of water gets eliminated. So what is left out? I have a benzene ring like this. You have nitrogen here. You have a double bond nitrogen here. And you have a Cl. This is called as benzene diazonium chloride. Benzene diazonium chloride. It is a red colored dye. It's a red colored dye. This reaction is called as diazotization. So formation of a dye will be called as a diazotization reaction. This is red in color. Benzene diazonium chloride is red in color. Now using this benzene diazonium chloride, we can prepare haloarenes. Now, when this benzene diazonium chloride is treated with cuprous chloride in HCl, cuprous bromide in hydrogen bromide, or if it is treated with potassium iodide, or if it is treated with fluoroboric acid, all right, you get haloarenes. Now, that reaction is called as Sand-Meyers reaction. It's called as Sand-Meyers reaction. For Sand-Meyers reaction, the basic requirement is for benzene diazonium chloride. This benzene diazonium chloride will be treated with various other compounds. Now you see, benzene diazonium chloride, we will represent like this: benzene diazonium chloride N double bond N Cl. This benzene diazonium chloride, when treated with or when heated with cuprous chloride and HCl, cuprous chloride and HCl, what happens is this will decompose and give you nitrogen gas. This will decompose to give you nitrogen gas. What else is left out? You have a benzene ring and you have what? Cl. This is called as chlorobenzene. This is called as what? Chlorobenzene. Is chlorobenzene an haloarene? Is chlorobenzene a haloarene?
Yes, sir.
Now, similarly, you see, all these reactions are Sand-Meyers reaction. Now, if you take benzene diazonium chloride and if you treat it with cuprous bromide and hydrogen bromide, see, what happens is this 2 nitrogen gets eliminated as what gas? Nitrogen gas. This chlorine and copper gets eliminated as cuprous chloride. In place of Cl, what goes? Br. Therefore, you get a benzene ring. So this is called as bromobenzene. It is called as bromobenzene. Now, similarly, when benzene diazonium chloride is treated with potassium iodide, what happens? Now, K and Cl gets eliminated as KCl. These 2 nitrogen gas gets eliminated as HN2 gas. What else is left out? You have a benzene ring and you have iodine. So you can prepare iodobenzene. So all these 3 reactions are called as Sand-Meyers reaction. So reaction of freshly prepared benzene diazonium chloride, treated with copper chloride and HCl gives chlorobenzene. with copper bromide, hydrogen bromide gives you bromobenzene. And when benzene diazoxide chloride is treated with potassium iodide, you get iodobenzene. All these are examples for haloarenes. One more reaction we should write. You cannot directly fluorinate this. You cannot fluorinate benzene diazoxide chloride directly. So if you have to prepare fluorobenzene, what we are supposed to do? The fourth reaction is this benzene diazoxide chloride is treated with fluoroboric acid. It is treated with fluoroboric acid. Fluoroboric acid. When it is treated with fluoroboric acid, what happens is this chlorine and this hydrogen get eliminated as HCl. In place of chlorine, BF4 goes. Therefore, you have a benzene ring, you have double bond N, and this is positive in character because chlorine moves away and you get BF4 minus. It's ionic bond. This when we heat, these two nitrogen gets eliminated as N2 gas. From boron trifluoride, tetrafluoride, boron trifluoride gets eliminated. See, BF4 we have. So BF3 gets eliminated as a byproduct. What else you have? You have a benzene ring and F, fluorobenzene. You will have what? Fluorobenzene. This reaction is not called as Sandmeyer's reaction. This reaction is called as Ball-Scheisman's reaction. SCHIEMANN, Ball-Scheisman reaction. All right. So BALZ, SCHIEMANN, Ball-Scheisman reaction. So direct fluorination of benzene diazoxide chloride is not possible. Therefore, it is reacted with fluoroboric acid to form an intermediate compound, which decomposes to form fluorobenzene. Followed with this?
Yes, sir.
So
Yes,
these
sir.
are the methods in which we can prepare haloarenes. One is by halogenation of benzene. I taught you. The next one is from benzene diazoxide chloride. This is benzene diazoxide chloride. All these three are called as Sandmeyer's reaction. And this is called as Ball-Scheisman reaction. We learned this. One more method is there here. It is called as Hunts-Dicker reaction. What is this Hunts-Dicker reaction? Silver salt of benzoic acid. Silver benzoate it is. C6H5, that is a benzene ring. COOH. This when you brominate, heat it, what happens? This COO gets eliminated as carbon dioxide. This bromine, we can write it as Br and Br. It gets eliminated as AgBr. What else is left out? You have a benzene ring and you have this bromine. So you get bromine. So bromobenzene. This is called as Hunts-Dicker's reaction. Next, we have from aryl thallium compound. Aryl thallium compound. This is not in the syllabus. It looks complex. So we will not learn from aryl thallium compound. Hunts-Dicker's reaction, you remember. It's not there in the syllabus, but still you remember to work out maybe in the competitive exams. This also you can go to. This is nothing but benzene. This is thallium salt. When it's benzene and thallium salt are reacted, you get finally aryl iodide. All right, so this reaction looks complex. The next one, physical properties. What are the physical properties of haloarenes? Haloarenes are colorless liquid or crystalline solids. It can be a liquid or it can be a solid. Solubility, they are insoluble in water, but dissolves readily in organic solvents. Insolubility is due to inability to form hydrogen bond. Why this haloarenes are insoluble in water? Because they have inability to form hydrogen bonding with water. Para-isomer is less soluble than orthoisomer. So para-isomer is less soluble than orthoisomer. Haloarenes are heavier than water. boiling point of haloarene follow the trend. Iodoarene is greater than bromoarene, bromoarene is greater than chloroarene. As the molecular mass increases, yesterday also I taught you, boiling point and melting point is directly proportional to molecular mass. As the molecular mass increases, boiling point and melting point increases. So this is with respect to the physical properties of the haloarenes. Chemical property, inert nature of chlorobenzene. Chlorobenzene is inert. Aryl halides are unreactive as compared to alkyl halides, as halogen atom of this compound is firmly attached and cannot be replaced by nucleophiles such as OH, NH, or CN. So nucleophilic addition reaction is not easy as it is possible with alkyl halides, because in case of aryl halides, the halogen atoms are firmly attached, strongly attached to the carbon atom. See here, chlorobenzene, chlorobenzene, you can see this chlorine is an electron donating group. So different resonance structures possible. Since chlorine is firmly attached to the carbon atom of the benzene ring, it will not undergo easily nucleophilic reaction. Nucleophilic substitution reaction. As easy as alkyl halides. Now you can observe this. I don't know whether you know the resonance structures or should I teach you the resonance structures? Sometime later we will learn the resonance structures, all right? But you should know substituted benzene. So this if I number as carbon 1, 2, 3, 4, 5, and 6. All right, carbon 1 contains chlorine. So adjacent to the carbon containing chlorine will be called as ortho position. So only one substituted benzene we can talk about ortho, meta, and para. Next to ortho will be what? Meta. And next to meta will be para. So only in case of substituted benzene, we can talk about ortho, meta, and para. Now, if you observe the resonance structure at ortho, at ortho position, at ortho position, you can see negative sign, electron rich, and also at para position. This is ortho position, this is para position, and this is ortho position. Nucleophile mean electron rich group. Since electron rich groups, this also rich, ortho position and para position also electron rich. Therefore, no reaction will take place. No reaction. That is why it is difficult for the molecules to undergo nucleophilic substitution reaction. Thus, delocalization of electron by resonance in aryl halides, haloarenes, brings extra stability and the double bond character between carbon and halogen. See here, extra stability carbon and halogen bond. This makes the bond stronger and shorter than pure single bond. However, under vigorous condition, the following nucleophilic substitution reactions are observed. Only at vigorous conditions, drastic conditions, nucleophilic substitutions are observed, but otherwise it will not undergo nucleophilic substitution reaction. See, these all are at vigorous conditions. All right. Now, nucleophilic substitution reaction, SN1 or SN reactions. Now, chlorobenzene, when heated with sodium hydroxide at 350 degrees Celsius and 500 atmospheres pressure. So what happens? This Na and Cl gets eliminated as NaCl, and in place of Cl, OH goes. Therefore, the product what we get is phenols. The product what we get is phenol. So chlorobenzene on heating with sodium hydroxide at high temperature, that's 350 degrees Celsius and 500 atmospheric pressure, nucleophilic substitution reaction takes place, forming phenol. Now, the second one is electrophilic aromatic substitution. Electrophilic aromatic substitution. Now, this electrophilic aromatic substitution is easy. We will learn this quickly. Now, electrophiles are electron deficient groups. Electron deficient groups. Now, generally positively charged. We learned one electrophile today, that is chloronium ion. I was teaching you about chloronium ion, Cl plus chlorination reaction. Now you can see at ortho position is negative, para position is negative. Therefore, now these electrophiles can attack ortho and para position easily because electron density is more at what? Ortho and para position. Are you following something?
Yes,
Yes,
sir.
sir.
Yeah. Because of the electron density at ortho and para position, electrophile can easily attack ortho and para position. Therefore, electrophilic substitution reactions are easy. That is what they've written, electrophilic aromatic substitution. Now, this chlorine is behaving like an electron donating group whenever it is bonded to a benzene. Generally, if you take CH3Cl, this bonded pair of electron will pull towards chlorine because chlorine is more electronegative. Chlorine gains negative charge and carbon gains positive charge. But in case of aromatic halides, any halogen for that matter, it will behave like an electron donating group. When it's behaving like an electron donating group, it will direct the reaction at ortho and para position. Therefore, it is called as ortho-para directing group. It is called as what? Ortho-para directing group. You can see the resonance structures, what we have written. At ortho position, it is minus sign, and para position, we have minus sign. So electrophile can attack ortho position and para position. So whenever we have electron donating group as a substituent on the benzene ring, we will get two products. One is ortho product, the other one is para product. Now, this is benzene. I will write one reaction. This is benzene. I'm showing the hydrogen atom at ortho position. Now, when it is nitrated, nitrated is equal volumes of concentrated nitric acid and sulfuric acid, nitrating mixture. Nitric acid, I will write it as OH and NO2. So what happens? This H and OH gets eliminated as water. In place of H, NO2 goes. So you'll get ortho product. If I take the second molecule, and if I show that molecule as para position, this hydrogen I'm showing at para. If you take one more molecule, OH and NO2, H and OH gets eliminated as water. In place of this H, what goes? NO2 goes. So you get para. This is para nitro chlorobenzene. Chlorobenzene. And this will be para orthonitro chlorobenzene. All right. So mixture of ortho and para, you will get two products you will get. Now you should remember, in case of nitration, in case of it will be in case of nitration, the electrophile is nitronium ion. Electrophile is nitronium ion, NO2 plus. Similarly, when chlorobenzene is brominated, you can see at ortho position you get bromine and also you get para position. So in case of bromination, the same reaction as I showed the reaction here. So in case of bromination, the electrophile is bromonium ion. What is this bromonium ion? Br plus bromonium ion. This is called as Friedel-Crafts reaction. It's called as Friedel-Crafts reaction. Chlorobenzene, when treated with alkyl halide, like methyl chloride, this hydrogen I can show, and I can write methyl chloride like this. CH3Cl. H and Cl gets eliminated as HCl. In place of H, CH3 goes. So orthomethyl, ortho compound you will get. And similarly, if I show the second hydrogen atom here for para, and if I write like this Cl and CH3, this H and CH3 Cl gets eliminated. HCl, in place of H, CH3 goes. Therefore, you get a para substituted product. All right. So in case of Friedel-Crafts alkylation, the electrophile is CH3 plus, CH3 plus. This is called as methyl carbocation. So what's the electrophile in the alkylation? It is methyl carbocation, CH3 plus. All right. Next is Woods-Fittix reaction. What is this Woods-Fittix reaction here? Woods Woods-Fittix reaction. It is the reaction between aryl halide and alkyl halide with sodium metal in dry ether. Woods-Fittix reaction. Woods reaction is only reaction of alkyl halides. Here it is a mixture of alkyl halides and aryl halides. Now alkyl halide, for an example, will take chlorobenzene. And aryl halide, alkyl halide, I will take methyl chloride, CH3Cl. We'll write it like this. When this is heated with sodium metal in dry ether, what happens? This Cl and this Cl will react with Na to form NaCl. And what happens? In place of Cl, what goes? CH3 goes. So you get toluene. So this is nothing but toluene. It's called as methyl benzene. It's called as toluene. Otherwise, it is called as what? Methyl benzene. This reaction is called as Woods-Fittix reaction. What is Woods-Fittix reaction? Reaction between aryl halide and alkyl halide with sodium metal in dry ether gives you alkyl benzenes. That's called as Woods-Fittix reaction. The next reaction is formation of Grignard reagent. What is this formation of Grignard reagent? I will write here, Grignard reagent. Formation of Grignard reagent. Now, aryl halide, any aryl halide, we will take bromobenzene. When this bromobenzene is heated with magnesium in dry ether, magnesium gets bonded between carbon and bromine. So you get C6H5 MgBr. This is phenyl magnesium bromide. This phenyl magnesium bromide is also an example for Grignard reagent, RMgX. Are you following this reaction, students?
Yes, sir.
So many reactions we have learned. All right, few more reactions possibly. Next is Ullmann's reaction. What is this Ullmann's reaction? This is iodobenzene, and this also is iodobenzene. This iodobenzene, when it's heated with copper, so iodine and copper gets eliminated as copper iodide, cupric iodide, and two benzene ring gets fused like this. That's called as diphenyl. This reaction is called as Ullmann's reaction. Reaction of iodobenzene with copper giving you diphenyl is called as iodobenzene. Now, I think we should finish the topic. Maybe in few minutes we'll finish off haloarenes. Let's continue with the next topic, alcohols, tomorrow. Now, a compound X with molecular formula C7H8 is treated with chlorine in the presence of ferric chloride. Which of the following compounds are formed? I didn't want to write the structures here. I couldn't draw that. So the molecular formula C7H8, the compound is this: benzene ring and CH3, toluene. C7H8, this is the molecular. Toluene is a molecular compound. When it is chlorinated in the presence of iron chloride, this toluene is also an orthopara-directing group. It's also an electron donating group. It is orthopara-directing group. When we say it is orthopara-directing group, you get orthochlorotoluene and you get parachlorotoluene. You get two products, parachlorotoluene. Chlorination, I taught you. All right. So CH3 is an electron donating group. Alkyl groups are electron donating group. Since alkyl groups are electron donating group, it is orthopara-directing group, and the reaction will take place at ortho position and para position. Therefore, you will get orthochlorotoluene and parachlorotoluene. Now, which of the following statement is correct? In electrophilic substitution, in the electrophilic substitution of toluene with bromine, iron 3 bromide acts as a Lewis acid. See, all catalyst FeCl3, AlCl3, FeBr3, all these are electron deficient group. It will act as a Lewis acid. Electron pair acceptors are called as Lewis acid. This is true. In a reaction of toluene with chlorine FeCl3, ortho and para isomers are easily separated. Just now I told you 2 products are formed, separated. Similar reactions with iodine is reversible in nature. Similar reaction. This reaction with iodine is reversible. Therefore, this also is true. And answer for this question is all of these, option D. Third question. Third question is not typed. All right, somewhere it'll be there in the last. All right, now this is enough. I think we've done maximum in this chapter, haloarenes, and some of the questions with haloarenes and haloarenes we will learn tomorrow. Right, somewhere it's missing. We will learn tomorrow, and then next class, that is Friday, then continue with alcohols. All right. We will stop.
Yes, sir.
Now, DDT, you remember DDT, how do you prepare DDT? This is important. DDT is prepared by the reaction of chloral. Chloral is trichloroacetaldehyde. Chloral is trichloroacetaldehyde. CCl3 and CH double bond O. And this is treated with chlorobenzene. See, chlorobenzene, 2 moles of chlorobenzene. 2 moles of chlorobenzene. They're shown 1 hydrogen here and Cl, and 1 more hydrogen of chlorobenzene, the second molecule here and Cl. These 2 will react to get eliminated as water in the presence of concentrated sulfuric acid. It's a dehydrating agent. So you get Cl3C, you have CH here, and you will have a benzene ring and Cl here, and you will have a benzene ring and with Cl here, benzene ring. So this is called as DDT. What is DDT? 2,2 bis parachlorophenyl 1,1,1 trichloroethane. So this is the IUPAC name of DDT. All right, we'll continue the class next. Thank you. Madam, I'll stop the class, ma'am.
Okay, sir. Thank you, sir.
Thank you, sir.
Thank you, sir.
Bye.